This is day 2 in the deposition of Dr. Peter F. Infante. This is in the District Court of Hidalgo County, Texas. The plaintiff is Eva Reina Ayala et al. The defendants are Phillips Properties, Inc. et al. Today's date is January 21, 2003. In case number C-4597-92-B. The appearances are the same as January 20th. We begin tape 4 at 9/18/22.
Dr. Infante, good morning.
Good morning.
I'm J.W. Dyer. I represent some of the defendants in this case. I'd like for you to help us out. As I understand it, your expertise that you're bringing to this case are in the fields of epidemiology. Is that right?
Yes.
And as I understand it, that means that you try to sit down and link various diseases to various causes. Is that a fair statement?
Yes.
All right. And in particular, in this case, we're focused on whether or not diseases, trying to identify what diseases may occur or are likely to occur as a result of exposure to benzene. Is that correct?
Yes.
And as I understand your testimony, what you've told us is that because there is some level of benzene in the groundwater beneath where folks live in a part of McAllen, that it's your opinion that they have an increased chance of developing some diseases that have been known to be related to benzene exposure. Is that a fair statement?
Well, that's part of it. The other part would be that there's the potential for, as a result of the benzene laying on top of the water, that there's that results in the potential for human exposure.
Okay.
I mean, if there's no exposure, then you don't have to be concerned about anything.
Now, as I understand it, you yourself have not developed any opinion about whether or not there is actual exposure to the people from the benzene that's sitting on the water, but that you relied on Dr. Madsen's opinion that there is some potential for exposure there.
Yes, and then some of the other reports that I looked at.
Okay, but you yourself have not developed any independent opinion as to whether or not there actually is any exposure to benzene for these folks that are in this area.
I haven't done any analysis, I think, would be the correct statement.
Okay, well, so to the extent that you have any opinion that there is any exposure, it's only based on what these other experts have looked at and determined. Is that fair enough?
Yes, and the reports that I saw about the monitoring.
Okay. Now, I'd like to understand a little better how this science of epidemiology works. As I understand it, at some time past, you had some suspicions, or actually you knew that you knew from previous studies that go way back that benzene will cause certain diseases. There was no doubt about that. Is that correct?
Yes.
Okay. And so you wanted to try to develop some sort of mechanism whereby you could quantify the likelihood that someone would develop a disease that was known to be caused by benzene if they were exposed to benzene. Is that correct?
Are you talking about past research I've done?
Yes, sir.
Or what?
Yes, sir.
Well, it wasn't a mechanism, no. I did the initial study that I published in The Lancet in 1977. It was to estimate what the relative risk was from individuals exposed to benzene.
Okay.
It wasn't characterized as developing a mechanism, that's all.
All right. Prior to 1977, was there any mechanism, was there any way to sit down and articulate the relationship between exposure to benzene and the likelihood that someone would develop one of these diseases that was associated with benzene exposure?
Well, there was information that benzene caused leukemia, and there were a lot of case reports of individuals with various types of blood diseases from exposure to benzene, and then there are estimates of, what, in some series of what percentage of those people then would go on to develop leukemia.
Okay. Then what was so prior to 77, we knew that there were certain diseases that were caused by benzene, and what you've just told me is that there was also some ability to try to state the relationship between exposure to benzene and the likelihood to develop a disease caused by benzene. Then what was the purpose of your study in 1977?
Objection.
If we already knew those things, what were you trying to accomplish in your study in 77?
Objection form.
To estimate what the relative risk was.
Okay. Now, as I understand it, you did in fact, as a result of your 1977 study, you did in fact come up with a mechanism or a model or something that would allow you to say, this is what I believe the relationship is between exposure and the likelihood that someone will develop a disease caused by benzene. Is that accurate?
Objection form.
I wouldn't quite put it in those terms, but I mean, the study demonstrated what, there were significantly elevated relative risks of leukemia in the pliafilm cohort.
Okay. Now, and as I understand, a cohort essentially is a group of people that you've identified and that you use to develop the statistics so that you can show this relationship between exposure and actually developing a disease due to exposure. Is that correct?
Well, that's what you're studying, yes.
Okay. And in 1977, you and some others actually sat down and identified a group of workers and analyzed and came up with some type of estimate of the amount of exposure that each of those workers had had over time to benzene. Is that correct?
Objection form.
No, at the time that was a categorical determination. Either were exposed or they weren't exposed.
Okay, it was either, okay. How was it then that you began to develop some sort of relationship between the amount of exposure that they had and the likelihood that they would develop a disease caused by benzene?
Well, that came about later through quantitative risk assessments that were done.
Okay, and could you explain to the jury how you did that? How you did these quantitative risk analysis?
Well, what you do is you estimate what the exposure is and then look at the relative risk and try to, and sometimes you have different groups of exposure, and then you look at the relative risk in terms of increments of exposure and see if you can determine a dose response, or you estimate dose response from that.
Okay. Can you explain to the jury what dose response means?
Well, dose response means that what is the response of the disease in relation to a certain exposure to the chemical being studied.
Okay. So, if I'm understanding what you're telling me, you look at different groups of folks, you estimate the amount of exposure they've had to benzene, and you also then look at how many of those folks eventually develop a disease that is known to be related to benzene?
Well, you look at, I mean, if you were doing a benzene dose response, you would look at individuals exposed to benzene, and then you would categorize them by different amounts of exposure, and then look at their risk of developing disease in relation to those different amounts of exposure.
I didn't hear you.
You would look at their risk in relation to the different amounts of exposure, in other words, your exposure categories, and see what the relationship is to different amounts of benzene exposure in relation to relative risk of developing the disease. That's called dose response.
When you say that you look at amount of exposure, can you explain to the jury how you express amounts of exposure?
Well, amounts of exposure can be estimated in various ways, and they all have their limitations. One is you could look simply at, if you had the data available at various levels of exposure. You could look at length of exposure. You could look at cumulative dose of exposure. You could look at, if you had data available, highest level of exposure. Or you could look at average level of exposure, average intensity of exposure. And as you increase those, see if there's an increase in the risk. There are, and duration of employment is one that's used, but there are limitations to, they all have their pitfalls, but those are standard categories of exposure that are used.
Okay, so now, can you explain to the jury when you say one way of expressing it is in amount of exposure? I believe that was what you told me was one category. What is that?
Well, you could classify amount of exposure by level of exposure. Or
When you
by
say level, I mean
the intensity of exposure. So
whether it's a little bit or a lot
right,
more.
was someone exposed to a tenth of a part per million, or half a part per million, or 1 part per million? Those would be different levels of exposure. And then in terms of levels, you could look at peak levels of exposure, or you could look at average intensity of exposure, or average level of exposure. Okay, that's one way of determining. You could also define exposure as what's called the cumulative dose of exposure, which means it's a product of the length of exposure times the level of exposure. You could define exposure by duration of employment, even though that has quite a few pitfalls. It's really not a very good one, but it's an estimate of exposure that could be used.
In the studies that you've done, have you reached any conclusion as to what the most accurate way of expressing exposure is? And I'm going to be talking to you about benzene and nothing else today,
right.
So you
Good.
and I can have that understanding. And I'm only talking about benzene, so if we're talking about, we don't need to sidetrack on other ones. But as it applies to benzene, do you have an opinion as to which is the most accurate way in an epidemic, in your type of studies, to express exposure?
Well, I mean, in a study, you could, exposures are expressed by all those various measures that I indicated before, specifically related to the toxicology of benzene. It's related to, I think, 2 things. One is the cumulative exposure and how you receive that cumulative exposure.
Okay. Cumulative exposure is you take the estimated intensity of the exposure. In other words, are you getting 1 part per million? Are you getting 10 parts per million or whatever? Is that correct? And you multiply it by the time that you're exposed to that level?
And that would be cumulative exposure.
And then
that has a bearing on it. And then also how you receive that cumulative exposure.
Could you explain that? What do you mean by how you receive it?
Well, is it a constant exposure or is it intermittent exposure?
Okay.
And there's evidence to suggest that intermittent exposure to even a lesser amount of benzene can cause more disease and more genetic damage.
So you're saying that if you were comparing, your experience tells you that if you were comparing exposure to, say, 100 parts per million benzene, if it would come and go, that a person actually has an increased chance of developing a disease due to benzene than if it were constant.
100 parts per million, like days or years or something, you just have to make it cumulative. I'm not talking about a level. So we're
Okay.
clear on that. I think that's what.
All right, so let's say that a person was exposed to 100 parts per million benzene once a day, 12 times a year. As I understand what you're telling me, you would expect that person to have a higher risk of developing disease than a person who spent 12 days straight at 100 parts per million.
Objection.
Is
Well,
that-
not exactly. That's getting a bit, specific. We don't have data specifically on that scenario.
Okay.
But if you say 100 parts per million one time a day, you mean 100 parts per million
No, 1 day out of the month.
one day out of the month exposed to 100 parts per million.
Yes, sir.
And for how long during that day?
Let's go ahead and say a 24-hour period. Let's say that 1 day out of the month, the person is exposed to 100 parts per million benzene for 24 hours over a year's time. And compare that to a person who, during that same year's time, is exposed to 100 parts per billion benzene for 12 days straight. Is your research told you that there's a difference in risk associated with those two scenarios?
Well, not exactly those two scenarios, no. I mean, the studies that have been done have shown, like, the intermittency is maybe, 3 days you're exposed, then 3 days you're not. 3 days you are, 3 days you aren't, or every other day. I haven't seen anything like, one time a month
Can
that I
you?
can recall.
Okay. Okay.
And
Now
then the gist of it is, it's given the same cumulative dose, if you receive that dose intermittently, it may have looks like it has more toxic effect than if you were given the same cumulative dose continuously.
Okay. I want to come back to that. I want to go back a little bit more to just so that I understand the basics of your analysis. What I think I've understood you to say is that in doing this study that you did, for example, on the ply film, and since then, you've taken groups of people, you have estimated the levels of exposure that they've had and the time that they've been exposed to that to come up with this cumulative amount, and that you then have compared these groups in such a way as to determine the frequency that someone out of that group has developed a disease that's due to benzene.
Objection.
Is that correct?
I'm sorry, you misunderstood me. I didn't clarify my testimony.
All right.
It isn't from taking epidemiological data and doing that. It's using toxicological data, experimental data There are several studies, well, more than several, show that you can get more disease from benzene even if you give less of a cumulative dose on an intermittent basis.
Okay, and I want to come
So
back
it
to this.
it wasn't based on epidemiological studies. It was based on animal cancer studies, animal studies affecting DNA or breaking chromosomes, animal studies showing benzene and benzene metabolites causing aplastic anemia. It was
Okay.
that kind of data. Those kind of data.
And I'm sorry, because I do want to come to this intermittent versus constant exposure, but I want to come to that a little bit later. I want to go back to something that I want to make sure that I understand this basically even more fundamentally, and that is your goal when you were doing the 77 study and subsequent work was to try to understand the relationship between exposure and the likelihood that someone would develop a disease that was caused by benzene. And you've told us that when you talk about exposure, that the two major factors that you think need to be examined are how it was received and the cumulative dosage. Is that fair? Objection?
No, yeah, but, well, that's since that time, not in 77 when I did my study. All the studies that have been done that show that they related to intermittent exposure were done subsequent to that, like in the 80s.
So initially you were focusing on cumulative dosage.
No, initially just focusing on categorically individuals exposed to benzene. What is their relative risk of developing
What's their what?
the disease? Categorically, individuals exposed to benzene, what is their risk of developing disease?
So initially you wanted to compare people that were exposed at any level to people that weren't exposed that you could determine and see if there was a difference in those two groups.
Essentially, to the standard population,
Okay.
comparing them to the standard population.
Now, could you explain to the jury what you mean by the standard population?
Well, in the initial Plavfilm study, actually had two comparison groups. One, we compared the observed mortality, like leukemia, to the U.S. standard population, which means these were white males, so we compared them. The cancer in the benzene-exposed individuals to the U.S. standard population of white males, using mortality rates, the U.S. standard population of white males, to see if they died at any different frequency from various diseases than a standard population of the United States adjusted for age, sex, and race.
So you would take,
That was one. Then we also compared them to, I think, fiberglass cohort. It was an industry from another group. So we had, in the initial publication, we had two comparison groups that we analyzed separately.
so what you did is you took and essentially looked at the U.S. population and the data that had been published on what number of folks died of leukemia-type problems over a period of time, and used that as a baseline, and you compared that to what you were seeing in the number of folks that had died of leukemia-related diseases that had worked at these two factories.
And using the rates for the U.S. population over the same period of time that the benzene cohort was followed.
Okay.
And over those same, adjusting for age.
Now, when you use the standard population as a baseline, as in other words, you're saying this is what we're saying is in effect normal, and we're trying to compare it to the folks that are working at this plant to see if they're different.
Well, to see if their mortality rates are different.
Yes, sir.
Okay.
And now, when you say the mortality rates, we are talking about, when you're comparing it to the workers, were you just saying mortality rates in general, or were you saying mortality rates that were due to benzene-related illnesses?
Well, the benzene, looking at the mortality rates of the benzene-exposed workers,
Okay.
comparing them to the mortality rates of the standard population.
So you weren't, when you were looking at the workers in the plant, you weren't trying to determine what they died of, you just were saying they worked at the plant and they died, and so that number got treated as a death?
No, we did both. You look at all causes of death, and then you look at specific causes of death, so both.
Okay. Well, folks that died for things that were obviously not related to benzene exposure, someone fell off a ladder and died or something of that nature, did he get taken out of these numbers, or did he get left in the numbers?
No, he's left in there. It would
Okay.
be like an accidental death.
Okay.
And then you would compare that to the standard population of the United States, the number of accidental deaths.
So when you use the standard population as a baseline, you use it both in terms of overall numbers, but then you also go back and try to separate it out for benzene-related deaths in the standard population?
Well, you don't know what the benzene-related deaths are until you do the study.
Okay.
So you're looking really at, you could look at all causes of death.
Right.
And if you're interested in cancer, you'd look at cancer deaths.
So in the ply film study, what did you use as the normal rate? Did you compare the total deaths at the plant over a period of time versus the total deaths in the standard U.S. population? Or did you compare the deaths that were due to things that were possibly linked to benzene to the total deaths in the same period of time in the standard population? Objection.
Well, you can have some a priori hypotheses about what diseases are related to benzene exposure, but when you do these studies, you just a cohort mortality study. Often you're looking at all
deaths?
All deaths. But I mean, you're looking at specific deaths in the study group. In this case, it would be a benzene cohort, and you're comparing the frequency of deaths in that study to the frequency of deaths in the standard population, adjusted for age, sex, race, and calendar time period.
Okay. When you say adjusted for age, sex, calendar time period, what you're saying is that if you've got a certain age group that worked at the plant, and for a certain time period, calendar time period, in other words, a 10-year span, that you're going to look at the total number of deaths that occurred during that 10-year span for white males in those age groups, and you're going to compare that to the total amount of deaths that occurred in white males during that time period in the general population of the United States. Is that right?
Yeah, and adjusted for the number of people.
Okay.
Yes, you wouldn't just make it. You obviously have a lot more deaths from the entire United States than you would from a cohort of 748 workers.
So when you say
make an adjustment for the number of people in the study.
So if you had 100 people working at the plant, and over a 10-year period, 8 of them died, then you would compare 8 out of 100 that died to the general population for the same age group of folks in the general population of the United States to see if there was 8 per 100 in the general population, more or less. I mean, you're trying to compare whether there's a rate, the rate in the general population is greater than or less than the rate of deaths at the plant. Is that right?
You're comparing the rate of death in your study population to the standard population.
Okay. And is the rate of death at the plant, are the deaths that you're examining at the plant all deaths, or are they deaths that are due to do you try to narrow the field down to say these are deaths that are due to health-related causes?
Well, when we did the benzene study, we were mostly concerned about, lymphohematopoietic cancers, so we focused on that. but you could do a study and look at all causes.
Okay,
Yeah.
but when you're focusing on trying to do a study to determine whether or not there's a relationship between benzene exposure and health-related deaths, then y'all did narrow the field to folks that had health-related deaths. Is that correct?
Objection.
I mean, you're not narrowing it to health-related deaths.
Well, you didn't use all deaths at the plant, did you? Or did you?
They were included in the analyses, yes.
Okay. But in your conclusion that there's a relationship between benzene exposure and health-related deaths, you would exclude deaths that occurred, things other than health-related deaths, would you not?
You mean benzene-related deaths?
Yes, sir.
You're saying health-related
Well,
deaths.
okay, let's narrow it down. Did y'all in fact try to take that group of workers and examine the causes of death, and in developing the relationship between benzene exposure and the amount of deaths that occurred, you only used those that actually had died due to something that you felt like could be benzene related, or did you use all deaths?
Objection.
Well, when we did the study initially, I think we focused on hematopoietic cancer. So we were looking at the, and I think all causes of death also as a category. I don't believe we ever published, for every cause of death in that cohort. I mean, one could do that, but it was a small cohort. So we focused on lymphohematopoietic cancer deaths. So you look really at the rate in the exposed group and compare that to the death rate for those same causes in the comparison group.
Okay. When you say you compare them to the death rate for those same causes in the general population, how does that work? Did you take the general population and you had data there that somewhat adjusted the general population death rate to something that was related to benzene?
Objection.
Well, you take the death rates in the general population and you adjust that to the person years and the ages of the individuals in the cohort. So then you come up with an expected number of deaths based on the death rate for the various causes in the standard population.
Okay.
So in other words, you might say, well, there were 3 deaths from this particular cause in the benzene cohort, and you would have expected 2, or you would have expected 5, whatever.
All right.
So you're generating an expected number by using the standard population. If people in the benzene cohort died from these causes at the same rate as the standard population.
In your initial test then, or study, you were just simply looking at whether or not there was an increased death rate of folks in these plants, and you really weren't looking at exposure levels, as I understand it. Is that correct?
That's correct.
When
I mean, we weren't looking at it in relation to exposure levels.
you took all the workers at the plant just to see if you had more deaths at that plant than you would have expected when you compared it to just the general population.
Well, we took the workers involved in the plant mill that were exposed to benzene.
Okay. Now, at what point did you begin to develop information about the relationship between cumulative exposure and the death rate?
No, that didn't begin until we started doing quantitative risk assessments for benzene.
Okay. And how did you go about doing that?
I mentioned that earlier, like you take a group of individuals exposed to benzene, you categorize them by exposure, and you look at their relative risk of death by various categories of exposure.
Okay. How did you develop the information with respect to the level of exposure?
Well, you estimate that from industrial hygiene data.
Now, were you using information that was provided through other studies by others, or were you developing this information yourself?
Objection.
In other words, did you go out and you and others under your direct supervision go out and specifically investigate groups and discern yourself through monitoring or through some sort of access to data that was done on a regular basis at these locations, what their exposure levels were, or were you relying on work that had been done by others where they reported this?
Objection.
Well, in the initial risk assessment on benzene that I published with co-authors, we relied on for the first benzene risk assessment, we relied upon what the exposure levels were at the calendar time period. And we assumed that the workers were exposed to those levels.
Okay. As you developed this understanding of this relationship, on one hand, as I understand it, if you were going to lay this out on a graph, on one scale, one axis, you would have cumulative exposure, cumulative dosage, or how would you express it on what would those two axes, what would be the
Well,
units that you would use?
in the initial publication, we used cumulative exposure in relation to risk or probability of developing leukemia.
Okay, so on one axis you've got ppm person years.
ppm years.
Okay. And on the other axis, your unit is what?
Was risk per thousand.
In other words, would be one person per thousand, two persons per thousand, something like that?
Yeah, elevated risk in units of per thousand.
Now, as I understood your testimony yesterday, initially, y'all either chose or let me ask you, you told me yesterday that this developed into a linear relationship. Is that true?
Objection.
Or did y'all just choose a linear relationship, or how did that come about?
Objection.
What I'm saying, we used a linear model to estimate benzene exposure.
Okay, why did you use a linear model?
Well, it's done by, that's what regulatory agencies usually use, is a linear non-threshold model for benzene and leukemia.
Are there other models that could be used?
People could use other models, yes.
Okay. Why is it that that model was chosen?
Well, there wasn't any basis really to choose any other model, and the linear non-threshold model for carcinogens with epidemiological data is by convention what has been used.
Okay. Well, but if you're doing a statistical analysis of data, you would plot up on a chart your various data points, and then you would try to figure out what the best fit expression of those points would be, wouldn't you?
Usually you see which, if you're not comparing one model to the other, you're comparing to see if one model fits the data.
Yes, sir.
Okay, so you're not comparing one model to the other, you're comparing one model to the data, and then you select the model that you think makes the most biological sense.
Okay, and is that what was done? Is that how you came up with the linear model?
Well, initially we used a linear model because we only had one data point, so we used a one-hit model, so that is linear at low exposure.
Okay. As time has gone on and you've developed more data, does the linear model still, is that still your model of choice?
I would, for low exposure levels, yes, I would think so.
Okay. Now, just for the jury, and I think that might be a good time, let's go up here to the chalkboard for just a second. If you don't mind, I'd like the jury to understand what you mean by a linear model. We talked about this graph, and I think you told me that on one axis on this graph, I think you could stand up with me, and you can probably enlarge the camera. Before we make those lines bigger. Can I get a light on that?
Yeah, the lights on the right. There you go.
There, is that better? Now, you told me that on one axis we would have risk in terms of what? Incidences of disease per thousand?
Excess risk of leukemia per 1,000 workers. You're talking specifically about the initial risk assessment that I published.
Yes, sir.
Okay, right.
So this would be excess risk, and it would be expressed in terms of what?
Excess risk per 1,000
Per
workers.
1,000?
Yeah,
Per 1,000 people?
right.
Okay.
Well, 1,000 workers, it was an occupational study.
When you say are you saying that there is going to be, for example, one increment would be one person per 1,000 would develop a disease? Is that what you're saying?
Well, leukemia specifically.
Leukemia specifically.
Yeah,
Okay. And so you would have, so this side would be, for example, number 1, 2, 3, and so on.
right.
Okay. And then this down here was what? What was the axis down on?
Cumulative exposure.
Cumulative exposure.
Right.
And this would be expressed in
Parts per million years.
parts per million years. So again, can you give me an idea of what kind of increment we would put that in? Would this be 1 part per million year, 2 parts per million year, or would it be 100, 200, or?
Well, let's see. I'm trying to figure it out so you can get it all on the graph. You could start with, say, 10, 20, 30, 40, 50 parts per million years. I mean, I'm not saying that mode, cumulative dose, is correct today, but at the time that I did the risk assessment, that's what we used.
And I understand that, well, help me out. When you say you're not sure if this would be accurate today, I think what you told me is that somehow we would need to adjust this to take into account whether it was intermittent or constant exposure. Is that correct?
Yes, you can do that, yes.
Is there anything else we would need to adjust it for in order to make it accurate based on the information you know today?
Well, I don't know what else you could adjust it for. I mean, there might be more information developed, but as we sit here now, I would say that, it's not bad. This is the only data we had available at the time, so, it was the
Okay.
best, thought it was the best we could do.
All right.
It doesn't mean that it's biologically correct, but it was the best we could do.
All right. Now, based on using these guidelines, as I understand, and I'm not trying to draw this to scale or anything else, but as I understand, when you say a linear relationship, what you're saying is that within the data areas that you had, the best explanation for how you could predict an increased risk as it related to an exposure level was a straight line.
Yeah, well, it'll flatten as it gets up.
Okay.
It's linear at low exposure levels.
Okay. So at some level, at some point in this data, when you say it's linear, you mean that it's a straight line as opposed to a curve.
Objection.
It's a straight, at lower exposure levels, the relationship is linear.
Okay. Now, and the way that you came up with this is that you would actually take groups of people and you would say, okay, here's a group of people, and what we found is that 3 out of 1,000 of that group of people, and I'm just using this for example, but you would come up with a data point that would say, we estimate that this group of people was exposed to a certain level of parts per million years, and that 3 out of that group of 1,000 adjusted developed a leukemia-related disease, and that would give you a data point. Is that right?
Well, there would be 3. Well, what you do is you generate the dose-response curve, and then you read it. You read what the risk is off of the dose-response curve.
Okay.
So you would say, for that dot that you just put there, you could say, well, at whatever cumulative exposure that is, and let's say that's the dose response, then you would expect 3 extra leukemia deaths per 1,000 workers.
Okay. And you did this for a variety of data, and they didn't all fall on a straight line. Some did, some didn't. But you tried to find a line that best described those points the best you could. Is that right?
Objection form, and let me also object, just a second, let me also object to the use of this, because now you're drawing dots and lines on there that bear no relationship to any real data.
I agree, but there's no relationship to any real event. I'm just trying to understand this process. Okay. So you did, let me understand. Did you have data points that you then tried to find a line that would best describe? Or how did you come up with this line?
Objection.
Well, in the initial study that I think we published in '82, we made 2 different assumptions of exposure, and so we, based on those 2 different assumptions of exposure, we used a one-hit model, and then that generated the dose-response curve. So we had actually 2, so you could see what the range of risk was from different cumulative doses. So you essentially had 2 estimates of, well, you had 2 data points. You had 1 data point, but 2 estimates of it.
Okay, and you just drew a line between those 2 points?
Well, you don't just draw a line. You use the one-hit model, and that determines what the relationship is.
As time has gone on and you've refined this information by looking at other data and other studies, from what you told me yesterday, I thought you had told me that within some range you had reached a conclusion that a linear model, a line, would best describe the likelihood of an increased risk at a certain level of exposure. Is that correct?
No, I said by convention, a linear non-threshold model is used for epidemiological data and cancer risk.
Do you have any type, at this point, do you have any kind of model that you feel like expresses the relationship, accurately expresses the relationship between the amount of exposure and the increased risk of developing a benzene-related disease?
Objection form.
Well, I think, at this point in time, I would, like I say, in terms of cumulative dose, if you could, you might make some adjustments to it, but I'm not sure how you could. But I would say the final risk assessment that OSHA relied upon in its 1987 standard seems like a reasonable risk assessment.
Okay, so the standard, at this point, from what I understand, you just told me, is the only thing that you would know to refer to would be the OSHA publication?
I said I thought that was a reasonable risk assessment. That was different from the one that myself and colleagues published in '82.
Okay. And does that assessment, take Mr. McLean's concerns out here, does that model or that expression result in, at least within a certain data area, the best way to describe the relationship is by virtue of a line? Is that correct?
Objection form.
Well, that was a dose response, yes, was generated using in that particular risk assessment I'm referring to, they used data from the NIOSH study, from the CMA study, and from the ODD study. Used all those data combined.
Okay. And the result was that between certain areas of cumulative exposure, you could see a relationship between that and the increased or the excess risk of disease.
Right.
And so in summarizing it all, essentially you come down to a point where you say, all right, within this range of exposure, you can predict the increased risk if you take that amount of exposure and you come up to this line, and that will tell you then what the excess risk is.
Right. Yes.
Correct?
Yes.
Now, can you help me?
That's an estimate of it.
Yes, sir. And this is all estimates because, in other words, people have taken the overall body of data and they have distilled it down to the best fit line that they can find through that data. Is that a fair way to characterize that?
No.
Okay. How do you come up with this line?
Well, first of all, you determine whether or not the data fit the model that you're using.
Okay.
And if the data fit the model, then you can use that model.
All right.
So then you would choose a model that you thought made the most biological sense. You wouldn't choose the model based on, well, this data fit the model, or this model fit the data a little bit better than the other one. You're not doing it that way.
You're not taking the data and trying to figure out the model that best fits it?
You're taking the model and you're seeing if the model fit the data. And if so, then that's an acceptable model to use.
Okay. So you started out, and this, when we talk about a model, this is a model, right? You're basically coming up with some sort of graph that allows you to predict if you have one known variable, then it will predict what the other variable is. Is that correct?
Objection form.
Yes.
Okay. So what we're trying to say is we're trying to come up with a mechanism whereby if we say we know the estimated cumulative exposure, we can then estimate what the increased risk is of developing the disease. Is that right?
That's right.
And at this point in time, there's some area there's some area of data within which the best way to do that, to accomplish this analysis, is by virtue of a straight line.
Objection form.
Is that correct?
I'm saying to extrapolate to the very lowest exposure levels, you assume a linear relationship.
Okay.
It may not, if you're at the high end of the dose response curve, it's going to start to flatten out, so that won't be linear.
Now, a minute ago you used the word extrapolate.
Right.
What I understand that to be, and if this is correct, please help me understand it better. What I understand to be when you extrapolate something, you take an area that you feel fairly comfortable in. It seems to be fairly well established, and you try to, because you don't have data in another area, you try to say that we can expect that same relationship to occur in this other area. You extend the relationship from a known area into an area that is unknown. Is that correct?
Objection.
That's correct.
And what I want to try to understand is, I want to try to understand where's the known area? Where are you extrapolating from? Can you give me an idea of where in the world of data about exposure levels and increased risk, where is it that you feel comfortable the data gives you a fairly justifiable feeling that there is a direct relationship, that you can say, okay, I feel comfortable saying that at a certain exposure level that the correct excess risk is fairly well established by this line. Can you give me some brackets, some area that we can feel comfortable about before we start extrapolating?
Objection.
Well, what you do is you take the data that you have, you develop the dose response, and then that gives you your estimate of risk along the entire dose response.
Okay, and can you tell me, based on the data that we have, what is the area of data we have? What is the lower bound? In other words, based on the data that you have that you feel like has been verified to the point that you're comfortable to use it, what is the low end of the cumulative exposure that results in an excess risk?
Objection.
Well, when you're doing a risk assessment, you assign cumulative exposure to the entire cohort.
Okay.
So you might have someone that was exposed for, let's say, 7 days to 10 parts per million, right? They would have 7 times 10 would be 70 parts per million days. You'd convert that to parts per million years, and that's where they would come out in terms of where they contribute on the dose response curve.
Okay. At this point, what I want to try to understand is, have you established a dose response curve for benzene-related illnesses?
Well, what I'm saying is I think that the best one still available is the one that OSHA used in its final risk assessment.
And now this dose response curve that they came up with, at some point, that curve doesn't start at 0 and go out for an indefinite amount. It's got some area of applicability. Is that correct?
Objection.
Well, no, you're extrapolating down to low levels. That's why you're doing the dose response.
Okay.
To determine what the risk is for areas on the curve where you don't have data. But that risk for all the areas of the curve is related to the areas on the curve where you specifically have exposure.
Where, and that's what I'm trying to find out, is where on that curve did you actually have data to support the establishment of the curve before you started extrapolating?
Objection.
What part of that curve is substantiated by actual known data that allowed you to establish the curve to begin with?
Objection.
Well, I can't, out of my top of my head, pull the numbers out. Now you'd have to look back at that final risk assessment.
Well, do you have that here?
No.
So you don't know what part of this curve is based on actual data and what part of the curve is extrapolated?
Objection.
Well, you'd be extrapolating to lower levels,
Okay.
and I guess you could also estimate what the risk is at higher levels. So in between, you've got actual estimates of risk. What I'm saying is I just don't remember offhand what the levels were. Like I said, they used the Rinsky study, the CMA study, and the Dow study. So you'd have to look back at that risk assessment to see what they were.
Okay. Can you tell me what publications I would look at to try to establish the point of the curve that was initially proven by the data points before extrapolation began?
Objection asked and answered.
Well, you're asking me what data were taken from those 3 studies to
Yes.
develop the dose response. And I'm saying you could find that in the OSHA final standard in the Federal Register. I don't remember offhand.
Okay. Can you come up here?
Well, let me see if I can remember some of it. I think in the CMA study, the one that was done by Wong, I think his dose response in that area was somewhere between 50 and 60 parts per million years.
Okay.
So
Resulted
that was
in.
from that. Well, all these data were combined into one risk assessment. In the NIOSH study, that was a higher. Generally, they had high and low exposures, but it was weighted, I think, with today what we would say was a higher exposure category. I can't remember what the average exposure was in that group. And then there was I don't know, could have been 50 parts per million. I just can't remember as we sit here. That was another data set that was combined in the risk assessment. And then the third was the study done by Dow, the odd bond study. And I think in that study, I think the average exposure was like 5.5 parts per million for 5.5. It was around 35 parts per million years was the midpoint of exposure in that. So I don't recall if our risk assessor, specifically what data points he used for that. It could be, that's at least a measure of central tendency of the exposure in that study. I mean, since then there have been other studies that show lower exposures and relative risk, that if you were to do a risk assessment like the NCI study, that's it includes people with high exposures, but it includes large numbers of people with much lower exposures than certainly was in the NIOSH study.
As we sit here today, do you have an opinion as to what the overall curve would look like if you were trying to express excess risk to cumulative exposure? What you told me is initially there was a linear portion that was proven as a result of various studies that were done. And I think you told me that as you get up into these higher portions, that instead of it being continuing on this straight line, that it begins to flatten out, as you said. Is that correct?
Objection form.
No, I did. Well, that last part's correct. Yeah, it would start to flatten out. But what I've said, there wasn't a linear portion that had been proven. I said that was the model that was accepted to use. It was a linear non-threshold model.
All right. Well,
It fit the data. I mean, someone could use a nonlinear model, and in fact, I think NIOSH did, and it fit the data also.
but in your opinion, the best way to analyze the data is using a linear model. Is that
A
your
linear
opinion?
non-threshold model.
Okay. Now, can you explain to the jury what you mean? You've explained what linear means. Linear means that the relationship travels along a straight line, and that you're comfortable saying that based on the data that you looked at, it's your opinion that within a certain range to describe it in a linear model with a straight line is accurate, but at high exposures, it's your opinion that this relationship doesn't continue on a straight line, but then begins to flatten out on a curve and flatten out. All right, correct so far?
Yes, and I'm saying at low exposures, the relationship would be linear.
Okay, now, is this flattening out relationship that you perceive based on extrapolation or based on actual data points and studies?
So it's based on the model that you use.
Okay.
And you see if the model fits the data.
All right. There is some data out here on the high end?
Yeah, there's data on the high end.
Okay. There's just not as much as there is in this portion here that you feel more comfortable about when you say that that's best described by a linear model. Is that right?
Objection.
I'm saying that a linear model can describe the data if it fits. Okay.
Okay. Now, where do you consider the low end to be when you talk about in low end exposures? Or maybe I'm not using the right term, so help me out if you think there's a better way of putting it. In other words, we've got this body of data that is established. Did you say the best way to describe it is by using a linear model? In other words, using a straight line. And you said that is true at low exposures?
Yes.
Okay. Does that...
Well, I'm saying that's the model that by convention is used.
Okay. At low exposures?
Yes.
All right. When you say at low exposure, what are we talking about in terms of cumulative exposure, parts per million years?
Objection form.
Well, I would say anything you would extrapolate below where you had actual observable data points.
Okay. What is our minimum observable data points? When I say minimum, in other words, what are we talking about in terms of cumulative exposure that you feel like are minimum data points that are valid points?
Objection form.
Well, as I mentioned earlier, in this particular risk assessment you're talking about, I can't remember what the data points offhand were that were used, but they used the data from those 3 studies. If you were to do a risk assessment now, I think I would include the Chinese study that was done by Hayes. And there, you can just look right in the table and see what the lowest data point is in that study. So that would be the lowest data point if you were doing a risk assessment on that study, and then the highest data point would be the highest data point in the study.
Okay. If you were sitting down today and trying to do a risk assessment of a particular set of folks.
Well, let's talk benzene and disease, since you said that's what
yes,
we're talking about.
and that's what I'm talking about. If you're talking about benzene-related diseases among people, are you saying, and if you were trying to look at the exposure level as being on the low end, would you use the Chinese study as your best guide to trying to predict what that exposure would be? Excuse me, what that risk would be?
I would say today I would use the Chinese study.
Okay. And my question is, because I'm not familiar with it,
Okay.
how far down on the exposure level, how far over towards none does the Chinese study come?
Objection.
I think the lowest exposure group in that study, in fact, a risk assessment was done using those data, I think was like 6.7 parts per million years.
Okay. So 6.7 parts per million years is I'm not a very good school teacher. I can't. .7 parts per million years is about as far as we can get over to the left-hand side of our chart with data that you feel like is reliable, that you can rely on in trying to determine what the excess risk would be?
Well, that's one data set that I would use if I were to do an assessment by either cumulative exposure, or you could also do intensity of exposure as well. So that's one data set. The other one I would use would be the Australian study.
Okay, and what is the smallest reliable exposure level in that study?
I'd have to look back in that study to see. I think for AML it was 0.1 ppm intensity of exposure to 0.2 ppm.
Okay, now that's based on intensities?
Right, it's based on level now.
Okay.
So I'm saying I would use both.
Okay. Did the Australian study allow you to develop data with respect to cumulative exposure?
I may have some data in there on cumulative exposure.
Okay. Do you
Yeah,
know
I would do
what?
both. I would do both. I'd use level and cumulative exposure.
Okay. What would be the lowest level of cumulative exposure that would be justified by the Australian study?
And I can't remember what it was. I mean, it's a pretty low exposure study because I think like the highest cumulative dose group in that study, I don't think there's hardly anybody exposed above 5 parts per million years.
Okay.
I think almost, 85–90% of the cohort or more was exposed below 5 parts per million years.
But you don't know how low? I mean, what would be what's the useful range of that study on the low end?
Objection.
I don't know what you mean. What do you mean?
Well, in other words, in order to try to develop a understanding of the excess risk of developing a benzene-related disease, what's the low end of exposure on a cumulative exposure basis that could be supported by that Australian study, in your opinion?
I don't remember all those data points.
Okay. But in your opinion, I mean, are you saying that you're willing to, do you think that data is valid data for developing a risk exposure analysis? Is that correct?
You asked me what other, I think indicated the study that I did in '82, then there was the study that was done by Ocean '87, and I'm saying there are these other, newer studies now, and these are the data sets that I would use to do risk assessment.
Okay. And near as you can remember, the lowest exposure that results in valid information in that Australian study is something below 5 parts per million years?
That was the highest.
Oh, that's the highest?
Yes, I believe so.
Then you don't know what the lowest is?
I can't recall.
Does it go into less than 1 part per million?
It may.
You just don't know?
Could be a little less than 1.
Okay. Now, so is it, and is it your conclusion that this linear model continues then down? I haven't done a very good job, so let me start over. Continues on a straight line all the way down below 6.7 part per million years?
Well, the linear model that you use would go straight down to 0. It would be linear.
Okay, but you've never seen any data that actually supports it going all the way to 0.
Well, when you use a linear model, you're assuming that the relationship is linear down to 0. You're using a linear non-threshold model.
Okay.
So it's going to go through at 0.
So are you saying, in your opinion, then, that based on the data that we have today and based on your analysis, that the best description, up until you get to some higher point, the best description of the relationship between excess risk and cumulative exposure is a straight line that starts at 0 and goes out.
Objection form. And JW, can I just have either an agreement with you that this is just being used for illustrative purposes and does not demonstrate any actual data?
Yes.
Okay.
It doesn't demonstrate any actual data, but it does demonstrate a relationship in general.
Being the line up,
Yes.
but not on any,
It's not the scale.
and it doesn't pertain to any actual numbers on either scale, on either the X or Y axis. Or
Well,
certainly
I think it does to the point that
certainly
you
on
say
the vertical axis.
Right, not on the vertical axis, no. I mean, I think I'm trying to get an understanding of where it does on the horizontal axis. So what I think I've understood you to say, Doctor, is that down to somewhere in the neighborhood of, well, you tell me, where is it that you feel like the data has been established that supports the proposition that there is a linear relationship? Where is the minimum level of data on the cumulative exposure axis that we have data to support the conclusion that a linear model will predict the risk, the excess risk of disease?
Objection form.
What I'm saying is that, a linear model is what's accepted to use. So, I mean, it's possible that, as I was mentioning yesterday, that you get more efficient metabolism to the toxic metabolites of benzene at lower levels of exposure. For example, you could, sorry, like down in the lower area, you can have this kind of relationship of the transformation to the toxic metabolites, but yet you're assuming a linear relationship from the model that you use with the epidemiological data.
Okay.
So I'm saying you have more efficient metabolism here, and you have less efficient metabolism at higher levels. So could end up here like.
Okay. Do you believe that this second curve that you've drawn actually more accurately predicts the true relationship between cumulative exposure and excess risk?
Well, I don't know. I'm just saying those are observations that are made. So what that would tell you is that at lower exposure levels, you may be underestimating the risk using a linear model.
Well,
Okay? But by convention, a linear model is used for human percentages to estimate risk into the areas where you don't have data.
So what I'm hearing you tell me is that the community of folks that are professionals that look into this type of thing at this point have accepted and have adopted a linear model to predict the relationship between excess risk and cumulative exposure, but that you have seen some indications that possibly another curve more along the lines of this one that you've drawn here would be more accurate.
Not exactly. I didn't say that. What I said is that regulatory agencies use a limited non-threshold model for carcinogens. And there are some data, the toxicological data, that show where you're exposing experimental animals, that you get a more efficient metabolism of benzene to the toxic metabolites at lower exposure levels. So I'm saying it's possible that using a linear model to extrapolate to low doses, you might be underestimating the risk at very low doses.
But having said that, having done all your studies,
I don't know how you would adjust. I don't know how you would adjust the risk assessment using a linear model to take into consideration that toxicological data. All that I'm saying is it indicates that you may underestimate the risk at low exposure levels.
but based on today,
Whether that would happen or not, I don't know.
so as you sit here today, your best estimate of how to deal with exposures under 6.7 parts per million per year is to continue the convention of using a linear model that would go to 0.
That's what regulatory agencies use, and I think that's reasonable to do, yes.
Okay.
I mean, that doesn't mean someone else couldn't use a different model.
All right. Now, let me ask you then.
Could we take a break?
Oh, sure. Off the record at 10:38:17. Record at 10:55:06.
Okay, Doctor, I believe that you told us that, in your opinion, the best way to predict, or the way that at this time, you feel like you can predict the excess risk relationship to cumulative exposure is to go ahead and use a linear model that starts at 0 and goes out. Is that correct?
Objection 4.
Well, I guess indirectly. I mean, I'm talking about what I said, it's a linear non-threshold model, and that it would go through 0 at 0 exposure in terms of risk. And we're talking about, these are all models that are, related to the occupational setting.
Okay. So, first of all, you say this is a model, this is a model. Okay. And I want to know, does this reflect your opinion of how it would be reasonably, how a person could reasonably predict risk, excess risk, as it relates to cumulative exposure?
Objection 4.
In your opinion?
Using the model that we discussed earlier and cumulative exposure, that would be one way of doing it, yes. And I also said that with some of the newer data, you could look at cumulative dose, you could look at intensity of exposure as well.
All right, those are other ways of looking at it, but I'm asking you, in your opinion, what is the best way to look at it?
Well, I'm saying one could look at it all three of those ways.
And you don't have a preference one over the other? You don't
Well, I
think-
would look both ways and see what the relationship is. I'd use cumulative dose, use level or intensity of exposure, or average intensity of exposure. If I were to do modeling now, I'd model the different ways and see what the relationship is.
All right. You haven't done any modeling with respect to the community that's being examined in this lawsuit.
That's right.
And so I'm asking you, in your professional opinion, what model do you use if you're trying to predict any excess risk that would be experienced by this community that's involved in this lawsuit? Would you use this model, which utilizes cumulative exposure, or would you use some other model?
Objection 4.
Well, I would use cumulative exposure, and I would use level of exposure we're talking about leukemia
Yes, sir.
and lymphoma. If I were trying to look at, say, effects on chromosomes, on DNA damage from benzene exposure, probably look at level of exposure and use safety factors.
Okay. Well, I believe you've told me that in this case, it's your opinion that there is an increased risk of benzene-related diseases that is being experienced by the people that live in the community that's the subject of this lawsuit. Is that correct?
Yes.
And when you reach that opinion, what model are you utilizing?
Well, I didn't model that because I don't know what the exposures are. I just know that there's increased exposure, and that would relate to increased risk. I haven't done any modeling to come up with any range of numbers.
All right. But in reaching that conclusion, I hear you saying that you are using some model that starts where there is no increased risk if there is no exposure, but immediately begins to find increased risk if there is any exposure.
Objection.
Is that correct?
Yes.
Okay, and...
We're talking leukemia here on this
Yes.
model. Okay.
Well, I'm talking about benzene-related illnesses that might be experienced by the people in this community that's subject to this lawsuit. That's everything I'm talking about today relates to benzene-related illnesses.
All right, and I said for other endpoints like genetic damage, you might look at level of exposure and apply safety factors
Okay.
as well.
What model do you have in mind, or what basis do you have for saying that these people would in fact be exposed to any kind of genetic damage, these people in this community in my county?
Well, you have studies of workers exposed showing cytogenetic damage at various levels of exposure.
Okay. What was the lowest level exposure that those workers had in the study that you would rely on to say that these people might have some type of molecular damage or cell damage?
Objection form.
Well, there are different studies. There's some epidemiologic data showing that you get chromosomal breakage from 0.1 part per million benzene exposure. There's studies of cytogenetic damage that Chemical Industry Institute of Toxicology study, I think I mentioned it, shows that, I mean, a single 6-hour exposure, you have a significant increase in chromosomal breakage, 6-hour exposure to 1 part per million.
Okay.
So you would take in all of that information.
So as I heard in your answer, the lowest threshold of data with respect to cell damage is at 0.1 part per million?
That I can recall, at 0.1 part per million or 1 part per million for a day.
Okay. Now,
And I'm not sure how I would model that, if I were to model that, or what I would do to estimate risk from that, because I haven't done that.
okay, so you haven't estimated any risk with respect to these people as it would relate to any kind of cell damage?
Not specifically.
You're not saying that in fact there is any risk?
Objection form.
Or are you?
No, I'm saying, yeah, there will be some risk.
So you're
I haven't
saying-
quantified it because I don't know what their exposures are.
All right, you're saying
Any
that
degree of certainty.
okay, you're saying that simply because there is benzene on the water under their property, that they are in fact exposed to an increased risk of cell damage?
Objection form.
You asked me that earlier, and I said not just because it's there, because as a result of it, there's the potential for human exposure.
Okay. Now, but my question is there's a difference between potential and actual risk, is there not? Increased risk, excuse me.
Objection form.
Well, I'm saying potential because, I don't know yet I haven't seen information on specifically. I've seen Manson's work, but I haven't seen more than that on what their actual exposure may be. I mean, he has his estimate. I think it's an average of, 240 micrograms per cubic meter, I believe, was in his report. And, we talked about that yesterday. So I'm saying on the basis of that, there's some increase in risk, so there'd be some increased exposure, but I haven't put any numbers on any of the diseases related to that extra exposure.
Well, let me ask you, if I had a 5-gallon jar of benzene sitting right here in a sealed glass container. Now, there is a possibility that you could become exposed. Are you also saying that there is an increased risk, that you are subjected to an increased risk by having that sealed glass jar of benzene sitting here?
No.
Objection form.
Okay, so there is a difference between possibility and risk,
Objection form.
correct?
I'm saying they have the potential for exposure from, the information that was provided. I don't know what that is. In the scenario you gave me, there wasn't any potential for exposure because it's just sitting there in a 5-gallon jug.
Okay.
So I would say there's no risk.
Okay. And you don't know yourself whether there is any potential for exposure to what benzene may be in the water under these people's properties yourself. You only rely on what Dr. Madsen tells you.
And the other information that we went over yesterday. I mean, to answer your question, I have not done any specific, analyses of groundwater or geographic configurations or anything else.
Okay. Now, I believe that we have the reports here that you referred to yesterday. Can you tell me exactly what Dr. Madsen says the exposure is?
Objection form, objection asked and answered.
I think in his estimate, he had an average of, 240 micrograms per cubic meter. And then we also talked about the potential for exposure through cracks in the soil, that the hydrocarbons that are floating on the contaminated water could migrate up through the soil. So those types of scenarios.
Okay, but there's a difference between potential and risk. You just told me that. Is that correct?
I'm saying there's the potential exposure, and carried with that would be the risk. I mean, if there's absolutely no exposure, nothing happens, and there won't be any risk.
Okay, and you don't know if in fact there's any exposure.
I didn't say that. I said I looked at Madsen's report and some of the other information that would indicate to me that there's some potential for exposure.
Some potential for exposure, but there has been no evidence that there's been any exposure.
Objection.
Is that correct?
I don't know that that's correct.
Are you aware of any evidence that there has been any exposure?
Objection form.
I looked at the information that was, the analysis Madsen did and some of the other soil stuff, and that tells me that there's a potential for it. Have I seen results from, I haven't seen any results from any exposure monitoring in the homes, if you're asking me that. I haven't seen such data.
All right. If I had a sealed jar of benzene sitting here beside you, you would have a potential for exposure, but you would have no exposure. Is that correct?
Objection form.
Well, I wouldn't even have the potential for exposure if you weren't going to do anything with it, if it was just going to sit there and it was a sealed jar.
Okay. Just simply sitting there, there would be no potential for exposure?
Right.
Okay. And my question to you is, have you seen any data to say that there has been any actual exposure in this case?
Objection form.
I thought I just answered that, didn't I?
Well, I'm not sure.
So I've looked at the Madsen's report and some of the other records that I looked at in terms of sampling the head space and those other things we went over yesterday. And I'm saying on the basis of that, I think there's potential for exposure, and that I have not seen the results of atmospheric sampling, which would be one way to look at exposure right now. And we also talked about modeling yesterday, that you could use modeling to predict exposure, and that provides something. And doing atmospheric monitoring can also provide a snapshot of exposure today. So you could use both.
So the answer to my question is that no, you've not seen any evidence of exposure.
Objection form.
I haven't seen any I haven't seen any sampling results from this area for benzene exposure.
So have you seen any evidence of exposure in this case?
Objection form asked and answered.
Well, aside from the modeling and from the other information, I've said there's potential. If what you mean by have I seen evidence of exposure, an actual sampling data point, the answer is no.
Now, I believe you told me, if we look back up here at this chart, that the best, in your opinion, the best way to describe the relationship between cumulative exposure and excess risk is a model that starts where any increment of exposure immediately results in an increase of risk. that right?
Objection form.
Yes.
Now, does that mean that every level of exposure to benzene by a human results in that human having some increased risk of developing a benzene-related illness?
That's what your assumption is when you use that model.
Is that your opinion?
Well, that's the model. That's the assumption that you make from that model.
Do you agree with that or not?
Yes.
Okay. Now, in the McAllen community, do you have any idea what the natural occurring level of benzene in the atmosphere is? In the atmosphere that people breathe as they walk around the streets in McAllen?
Objection form.
No.
You would agree with me that there would be some level of benzene in the air in McAllen?
Objection form.
Probably, yes.
And that would mean, based on your opinion of how things work, that those people, that the average guy walking around in the streets of McAllen is susceptible to some increased risk of developing benzene-related disease.
Objection form.
Yes.
Can you tell me how that level fits into your analysis of the increased risk that the people that are living in homes and operating businesses over this area that we're examining in this lawsuit have an increased risk?
Objection form.
Could you ask me that again?
Sure. How does the fact that anyone walking around in the McAllen area is exposed to benzene factor into your analysis with respect to the increased risk that these people that are living in this plume area or working in this plume area are exposed to?
Objection form.
Well, from the exposure they would receive from the contaminated groundwater, it would be in excess of normal background.
So your expectation is that if we went out and did air monitoring in the area above the plume, that we would find higher levels of benzene there than other places in McAllen?
Objection form.
Well, I don't know that other places in McAllen, I don't know. What I'm saying is that I think that by being on top of the contaminated water, that there's a potential for an elevated exposure to people living in those homes, and that would relate to an increase in risk. I mean, there might be other conditions, say everything else being equal, where other parts of McAllen, for what might be going on there, they might have a higher level of benzene exposure than people living over the plume. But then you got the potential for exposure from the hydrocarbons escaping through the soil and adding to their risk of exposure, because it adds to their benzene exposure.
You have the potential,
Yeah, right.
but you don't necessarily have any added exposure, do you?
Objection form.
Well, I'm not saying that. I'm saying if you don't, then there won't be any increase in risk.
Okay. And you've not gone out to do any kind of determination as to whether or not there has in fact been any increase in the amount of benzene that people are exposed to in the area of this plume?
Objection, asked and answered. That question has been asked at least 10 times. If we're going to keep going over the same ground over and over, let's stop this damn thing. I mean, this is getting to be ridiculous. He's been asked that question at least 10 times between yesterday and today.
I don't believe he has.
Well, he has. You've asked it at least 6 or 7 times just in the past half hour.
Dr. Infante, are you equating potential? Are you saying, well, explain to me your understanding when you say potential, how does that relate to risk?
All right, well, I'm saying they have the potential exposure from the various things that we talked about earlier today and yesterday. So to the extent that those situations occur, they'd have an increase in their exposure, so they have an increase in their risk.
Okay. Is there, as an expert, are you saying that there is a direct relationship between increase in potential and excess risk of benzene-related diseases?
Of course not.
Okay. But you are telling me that because there is an increased potential that these people in the area of examination in this case are subjected to an increased risk, excess risk of benzene-related diseases?
Judge inform estimates.
I think I discussed this already.
What's the answer to my question?
I answered the question already 6 times at least.
Are you telling me that because there's an increased potential of exposure to the people that live in this plume, that they have an excess risk of benzene-related diseases?
Judge inform estimates.
And I think that potential will, in fact, work out in some situations. So I'm saying that they'll have extra exposure, and it's the exposure that will result in the extra risk.
Okay. And what is it in your training and expertise that allows you to say that it will work out, that this potential will in fact work out, as you put it, to additional exposure?
Well, because of the, I think Mattson's report, the information that we talked about, the laboratory analyses, and then I think there was one situation I was aware of where someone was like digging a trench or something, some utility people, and they became, I guess, exposed to hydrocarbon fumes. So what I'm saying is you've got, this groundwater that's contaminated, and you're going to get, as I talked about yesterday, some fractures in the soil. That's my understanding. And the situation in which those facts bear out, I don't know. But taking that scenario, I'm saying it's going to result in the potential for exposure to, in various homes, and people have extra exposure, and that relates to extra risk.
Could you explain a little bit more about what this is that you're talking about, people digging a trench that were exposed to some sort of hydrocarbons?
Yeah, there was, I think either Mr. McLean told me, or it was, I can't remember if it was in a report that I saw or not at this point in time.
Well, I believe you have all the reports here today. Can you show me the report that would show where there'd been somebody digging a ditch that was exposed to some sort of hydrocarbons?
I don't know where it is offhand, but that was my understanding. Maybe Mr. McLean relayed that to me, and so I thought, well.
And how did this?
Pardon me?
We did not do the last.
Yeah, Mr. McLean may have relayed that scenario to me.
And how did this impact your decision that the increased potential, the potential for exposure will work out into actual exposure?
Well, that was like one example of the groundwater, obviously contaminated groundwater, getting to the surface. I thought that was one example of it.
So,
I mean, they weren't digging a 25-foot hole or whatever. These guys were utility people. I don't know exactly how deep they were digging, but they were overcome with hydrocarbon fumes. That was my understanding.
and so your professional opinion that this probability will in fact work out to increased exposure is premised on your understanding that this contaminated groundwater gets up to within levels that could be encountered by someone digging a normal trench.
That was the specific scenario as I understood it, yes. And then there was the other information that we talked about yesterday about cracks in the soil.
And so, if no such occurrence ever occurred, would that affect your opinion that this is eventually going to work out or not?
Objection form.
It's going to work out that this potential develops into actual exposure?
Well, if it works out that there's never any migration of the benzene from the contaminated water up to the surface and there's no exposure, then there won't be any extra risk.
Okay. Have you done anything to determine the numerical likelihood of an increased risk to any of these people in this community in McAllen that's the subject of this lawsuit?
Objection form asked and answered.
I haven't done any risk assessment.
Have you done anything in the way of investigating the historical medical data of any of the complainants in this lawsuit to determine if, in fact, it would reflect any kind of abnormal incidences of benzene-related illnesses?
We talked yesterday about what my task was for this. It was indicated in that letter. That's the only thing I've done.
So you haven't?
That's right.
A minute ago, you told me, I believe you told me what you felt like Mattson had said he estimated the potential for exposure to be. Did you give me a number a minute ago?
It's from his modeling.
From Mattson's figuring?
Yeah, what's in his report there.
Okay. Can you show me in the report that you produced where that number is?
Objection form asked and answered.
Well, it's table 1 or 2 of his
Okay,
report.
well, let's get his report out here and look at it.
Do you have it?
It's one of the exhibits here.
Evidence here. Well, it's not there that I can find.
Well, are these, yesterday you brought with you all the papers that you have examined in this case, is that correct?
It was here yesterday.
Okay, and it was marked as an exhibit, right?
I don't remember if it was or not.
Okay. You don't remember if all the papers that you brought yesterday were marked as an exhibit or not?
These papers were here when I got here. I didn't bring these.
Yesterday, you were handed a set of papers and asked to confirm whether or not these were all the documents that you had looked at in preparing this case. Is that correct?
That's right. No, I was given it subsequent to this date.
Subsequent to what date?
The date when these documents were produced.
Okay. But at the deposition yesterday, you were handed a set of documents and asked to confirm that that was all the documents that you had looked at in preparing your opinions in this case. Is that correct?
Yes, and then I had also mentioned that I had received the Madsen report subsequently.
Okay. I'm going to represent to you that Exhibit 3 to your deposition was what you have testified as being the materials that you were given and that you looked at in preparing your report.
It was the 196. You're missing part of there, but it goes to 196. There he is, it's just him.
Okay, this is Exhibit 3 as I look through these exhibits. Now, in here, pages that begin as labeled PI 69, I find an expert report by Jack B. Madsen. Now, I'd like you to look at that report and tell me if that is his report and if that is all the report from him that you're referring to when you talk about his calculations as to the potential exposure in this case.
No, there's another report that I think's dated August of 2010.
Okay, did that come before or after you wrote your report?
Well, it came after I wrote my report.
All right. My question to you is This is the only thing that you referred to prior to the time that you wrote your report and reached your conclusions. Is that correct?
Objection form.
That's the only written material that I had, yes. And I
Okay.
had discussions with Mr. McLean.
All right. Is there anything in that report that tells you what level he says the potential for exposure is?
Objection form.
No, he talks about different situations going on, but there's not a number in there. No.
Okay. Now, you say there is another report
Yes,
that you've looked at of his that came subsequent to this.
right.
All right. Is that report in here?
No.
And you're saying that it is in that report that he specifies a certain level of potential exposure?
Right.
And what do you recall that level to be?
Somewhere around 240 micrograms per cubic meter.
Okay, and how does that come out in parts per million?
Objection form, asked and answered.
If you know.
Well, you'd have to divide it by 3.2, and that would give you the answer.
Okay, so you take that number and divide by 3.2.
Right. Well, in parts per, they give you parts per billion.
That would give you parts per billion.
Right.
So how would you come up with parts per
And
million?
you just move the decimal point 3 places.
All right. So you would divide it by what?
1,000.
Divide it by 3.2 and then divide it again by 1,000,
Right.
and that would give you parts per million.
Right.
Do you know what the baseline rate of deaths related to benzene are for the McAllen area? Deaths related to diseases caused by benzene in the McAllen area?
Objection form.
I've never seen such information.
Okay. And because you have never come up with a numerical number for the excess risk to folks in this area in McAllen due to benzene exposure, because you've never come up with that number, there's no way for you to go and in fact look at the death data from this area to determine whether or not your prediction would be accurate or not. You've never made a prediction, so you can't determine whether that prediction is accurate. Is that correct?
Objection form, asked and answered.
I suppose one could calculate the death rate for various level hematopoietic cancers in the area and compare it to some other population.
Okay, but you haven't done that.
I haven't done that, no.
Okay, let's go ahead. It keeps bothering me, telling me I'm about to run out of time on tape, so let's just stop and change it now.
This concludes tape 4 in the deposition of Dr. Peter F. Infante, off the record at 11:33:37.
Sure. Take a break.